In this video, we will learn about chemical properties of carbon or organic compounds. So first we will learn combustion. Combustion is an act or instance of burning of a substance. Combustion is usually a rapid chemical reaction which produces heat and usually light. Combustion is basically an oxidation reaction. That means it happens in presence of oxygen. Combustible substances are used to produce heat or power by burning are called fuels. Nearly all solids liquids Nearly all solid, liquid or gaseous fuels are made up of the compounds of carbon. For example, carbon in all its allotropic forms burns in air and oxygen to give carbon dioxide with release of heat and light. So you can see carbon is reacting with oxygen to give carbon dioxide, heat and light. Natural gas, which is mainly methane, burns to give carbon dioxide and water. So CH4, that is methane, reacting with oxygen to give carbon dioxide, water, heat and light. Ethanol is a volatile and highly inflammable liquid. As it catches fire readily, it burns with a blue flame. So here we can see ethanol is reacting with oxygen to give carbon dioxide, water, and in this combustion we get heat along with bluish flame. Now ordinary cooking gas or LPG, that is liquefied petroleum gas, is normally a mixture of propane and butane or isobutane. So these are the alkanes. It burns with a bluish flame, producing large amount of heat. So propane reacting with oxygen to give carbon dioxide, water, heat and bluish flame. Butane also reacts with oxygen to give carbon dioxide, water, heat and bluish flame. So these are the components of LPG. Saturated hydrocarbons, that means the alkanes, generally give a clean bluish flame, whereas unsaturated hydrocarbons give a yellow flame with a black smoke. For example, methane, that is saturated hydrocarbon, burns in air with bluish flame, whereas ethene, that is C2H4, or ethyl, that is C2H2. So these are unsaturated hydrocarbons. They burn with a yellow sooty flame. This is because of higher percentage of carbon in unsaturated hydrocarbons. However, if supply of air and hence of oxygen is limited, then incomplete combustion will take place and even saturated hydrocarbons will burn with a smoky flame. Then substitution reactions. A substitution reaction is a type of chemical reaction where an atom or a functional group of a molecule is replaced or substituted by another equivalent atom or a functional group, like halogenation. For example, chlorination of alkanes in presence of light is a substitution reaction. For example, when a mixture of methane and chlorine is exposed to diffuse sunlight, hydrogen of methane is successively replaced by chlorine, giving a number of products. So we can say methane is there and it is reacting with chlorine in diffuse sunlight. So we get first chloromethane and HCl. So we can see that we are having CH4 here. So four hydrogens are there and this is reacting with chlorine. So here what happens, this chlorine is replacing the hydrogen. So we are getting here CH3Cl. So CH3Cl is the chloromethane and this is reacting again with chlorine to give dichloromethane along with HCl. This dichloromethane is reacting with chlorine to give trichloromethane, that we call chloroform, with HCl, and this chloroform or trichloromethane is reacting with chlorine to give carbon tetrachloride or tetrachloromethane along with HCl. Now, addition reactions. An addition reaction is a class of chemical reactions in which an atom or a group of atoms is added to a molecule or to form single bigger molecule. The addition reactions are characteristic reactions of unsaturated compounds, that is compound having double bond or triple bond. Thus, unsaturated compounds, that is alkenes, those are having double bond, and alkynes, those are having triple bond, undergo addition reactions. For example, addition of hydrogen to alkenes and alkynes takes place in the presence of catalysts like nickel, platinum, or palladium, and the product is saturated hydrocarbon. So we are having here ethene. that is alkene, and it reacts with hydrogen in presence of nickel and the temperature is 473 Kelvin. We get ethane and alkane. Now we have ethine, that is alkyne, and this is reacting with hydrogen in presence of nickel and 473 Kelvin. So we are getting ethene, that is alkene, and this is further reacting with hydrogen in presence of nickel and 473 Kelvin to give ethane, that is alkane. So ultimately we are ending up with alkane, that is a saturated hydrocarbon. The addition of hydrogen to an unsaturated compound is sometimes called hydrogenation because here the addition of hydrogen converts the unsaturation to saturation. An important application of hydrogenation is to get vegetable ghee from vegetable oils. Now we will see hydrogenation of oils. Vegetable oils such as mustard oil, coconut oil, groundnut oil, cottonseed oil, etc. are generally used as cooking medium. Chemically, oils are mixtures of esters of unsaturated higher fatty acids, that is, they contain carbon-carbon double bonds. Sometimes these oils some of these oils don't have very good smell and taste. To make oils more palatable, they are converted into semi-solid mass called vanaspati or vegetable ghee. This is done by hydrogenation of these oils. Hydrogen is passed in hot vegetable oil in the presence of finely divided nickel, that is a catalyst. So finely divided nickel is used to increase the surface area of the catalyst and to increase its catalytic power. So vegetable oil that is in liquid state is treated with hydrogen and the catalyst is nickel finely divided, and we get vegetable ghee that is in semi-solid state. Another important example of addition reaction is addition of water to alkenes. Ordinarily, water does not add directly, but alkenes add water in presence of dilute acids to form alcohols. For example, when a mixture of ethene and steam is passed over phosphoric acid, that is H3PO4, under pressure and at 573 Kelvin, ethanol is formed. So this is ethene and water is added in presence of phosphoric acid and the temperature is 573 Kelvin, we get ethanol. The addition of water to an alkene is known as hydration of alkene. Then oxidation. First we will see combustion. Carbon compounds are easily oxidized on combustion. For example, methane is reacting with oxygen at the process combustion. We get carbon dioxide, water and heat. Combustion is uncontrolled oxidation of the compound. Ethanol burns with a blue flame to form carbon dioxide and water. So this is ethanol and there is combustion to give carbon dioxide and water. Oxidation in the presence of an oxidizing agent. Now, those substances which are capable of removing hydrogen or adding oxygen to others are called oxidizing agents, since addition of oxygen or removal of hydrogen is known as oxidation. Alkaline or acidic potassium permanganate, that is KMnO4, acidified potassium dichromate, that is K2Cr2O7, hydrogen peroxide H2O2, or ozone, that is O3, etc. are commonly used for the oxidation of carbon compounds. For example, alkaline potassium permanganate, that we call Bayer's reagent, oxidizes ethanol to ethanoic acid. So here we have ethanol and this is oxidized in presence of alkaline KMnO4, we get ethanoic acid. I hope this topic is clear to you. Thank you.